Hello guys, welcome to this lesson. So in this lesson, we want to look at vectors. So we'll be talking about many aspects of vectors. We'll be talking about the position vectors, length of a vector, which is also known as the modulus of vector. We'll look at addition of vectors, subtraction of vectors. We'll look at multiplication and scalar multiplication of vectors. And we'll also look at angle between two vector and vector geometry. So we have so many subtopics that we want to cover. So I believe get your note, your pen, and follow along, and make sure you do the practice classworks, and also take your note and your assignment. Okay. So first of all, when we talk about vector, we are talking about as you know from physics, when we call an object a vector, we are talking about an object that has a number one magnitude. The object must have magnitude. Okay, so when we say magnitude, we are talking about the size of the object. So there must be magnitude, which is size. Okay, so you can quantify that thing in terms of size. For example, we are a vector because we can move, we have size, you have weight, so we are a vector, imagine a vector quantity. Okay, so we can also talk about the direction. So direction of the vector. Okay, so direction. So these two things are very important for a body or an object to be called a vector. It must possess these two capabilities. There must be magnitude. We must be able to describe the magnitude of the object numerically, and then you must be able to measure the direction of the object also numerically. Okay, so this is what is called a vector object or vector quantities. Okay, so vectors are quantities, they are bodies, they are objects like car, like bicycle, or any object that has magnitude and direction. They are said to be vectors. Okay, for example, your fridge and freezers at home, if you carry them, you just put them in one place, they will continue to be in that place forever. Okay, unless you carry it again. So you can see, so those kind of objects are scalar quantities because they only have weight, they only have size, which is magnitude, but they cannot move, they do not have direction. Okay, so when an object moves in a zigzag manner without a particular direction, we cannot quantify that object as a vector, because for an object to be a vector, there must be a direction of movement. Okay, the object direction of movement must be able to be described with respect to the north, east, south, and west, or with respect to the eight cardinal points, south, east, southwest, or northeast and northwest. So that is when we characterize object as a vector. So we are going to be looking at the four cardinal points in most of our explanations. Okay, so consider the four cardinal points and the eight cardinal points. Okay, so north, east, south, and west. So these are very, very important also in our study. So let's look at our preliminaries. So skill check, to check your understanding of before. Okay, so I don't know if you have seen this before, but I'm just going to, okay, so um, let's check what we have in the lesson. So I'm just going to scroll up to the first page of the lesson to see if that will have as well. Okay, so that's what we have. That's what we have. So skill check. Find the vectors A, B, and B, A in each case. So in these vectors, we've not really done things like this. So I think maybe we should go into the next lesson. So by the time we come back, you will understand what we are saying better. Okay. Alright, so vectors notation. A vector is a quantity which has both magnitude and size, which has both magnitude and direction, as we have been saying. Okay, so vector AB can be used to describe a displacement of A unit in the x direction and B unit in the y direction. So vectors are also described based on the Cartesian plane. Okay, so we can describe vector using the Cartesian coordinate system, the x and y axis. Okay, so the x-axis is also known as the I direction. This is xi, this is y, okay, and this is the origin. So the x direction is known as I, and the y direction is called j. Okay, so when we say vector AB, so vector notation, vector can be written as in form of this squared bracket or elongated bracket arranged vertically like this, and this is known as column vector. Column vector. Okay, we can also use this notation, that is vector can be written in form of components. We have AI plus bj. Okay, so this is called component form. Component notation. Okay, so these are two ways we can write vector. So anywhere you see the arrangement, in the first arrangement is a vector and it is called a column vector. If you see the second arrangement, we call it component form. So we can have two-dimensional vectors. Two-dimensional vectors. So two-dimensional vectors have only this kind of notation, AI plus bj, and then we have three-dimensional vectors. Three-dimensional vectors have three components, like AI plus bj plus ck. Okay, so like that. So three-dimensional vectors are represented in the form I, j, and k. I, j, k. Okay, the third element is called k. So three-dimensional vector comes from three-dimensional Cartesian coordinates, where we have a third axis that is called z-axis. Okay, so this is zk, and this is xi, and this is yj. So these are the notation given to those components. So a scalar is a quantity which has magnitude but no associated direction. So just as we said, scalar has no direction. Okay, so we cannot quantify scalar using ijk, because ijk are the direction of a vector, and they are what make a magnitude, or what they are what make a numerical values a vector component. So in two dimension, we can represent scalars as this. So what we just finished, talked about coordinate geometry in the lessons we had in before this one. So coordinate geometry. So the coordinate pair x comma y that we have, they are scalars, because they are just positions. They do not have direction. They are just representation of points on a Cartesian plane, so they can be regarded as a scalar. Okay, so they are not vectors. So when we arrange vectors, there's usually no direction, no notation of I and J, so we just have them like that. Okay, so the column vector can be represented as xi plus yj, where I and j are unit vectors or vector of length y in the x and y directions respectively. So as I have told you, they are called the column vectors, and then if we add another direction, which is k, which is called the z direction, then this is k. Okay, and their unit vectors, because their magnitude is 1. So the column vector xyz can be represented as xi plus yi plus zk, where I, j, k are unit vectors in the x, y, and z directions respectively. And then they can be written in column form as 3, 1 minus 1 minus 2. So you should be able to change from column to component. Okay, so this is column method, and this is component method. Okay, component method, 3i plus j minus 2k. So this vector means that you have 3 units in the x direction, 1 unit in the y direction, and minus 2 units in the z direction, or 2 units in the minus z direction, as the case may be. So these are the representation of vectors. And briefly, let's look at our examples. Write down using a column vector notation the displacement of the following. So we're going to start from the first one. We have A. So A, we have 1, comma 5 to 3, comma distance. So we are only to write them down. So when we talk about displacement, so I think we should briefly explain what displacement means. Okay. So displacement, as you know in physics, displacement is a distance with a direction. So when we say distance with a direction, that is displacement. Okay. In physics, distance is a scalar quantity because distance is just a measure of length. It has no direction. But when a distance comes with direction, it becomes a displacement. That is when you can describe a distance with respect to the north, south, east, and west, then we can talk about displacement. Okay, so displacement is distance with direction. So we can talk about the displacement of a straight line. As you know, we discussed distance between 2 points in coordinate geometry, and all those formula we use, they are scalar form. So we can also have uh, displacement or distance or length in vector form. So that means if we need to add a component, so if we have a of x1, y1, and b of x2, y2, okay, so we talk about the distance. The distance is given as the square root of s2 minus x1 squared plus y2 minus y1 squared, right? Yeah, fantastic. But this is in coordinate form. So in vector form, if we want to describe distance, we're going to subtract the component. So the distance, the displacement, okay, AB is also denoted as AB with arrow. Okay, so no, AB is usually defined as B minus A. You subtract the first vector from the second vector, okay, and this is going to be uh, x2 minus x1, okay, plus this is I plus y2 minus y1 G. Okay, so what's the difference between this one and this one? The difference is that we don't have the squares and the square root in this one. Okay, there's no square and there's no square root. So when we are finding the displacement of vector, we find them in a component form like this. So let me write this formula. So AB is called displacement, okay, from A to B, from A to B. Remember, these are vectors. So whenever you are writing vector, you put an arrow on the head of the letter. Okay. So and AB is calculated numerically as B minus A. Take note, it is B minus A. You subtract the first vector from the second vector. And if the components of B are x2, x1, x2, y2, okay, from what we have, the component of A are x1, y1. Then we can talk about the displacement as s2 minus x1, okay, y2 minus y1, okay, which in terms of a component, we can write it as s2 minus x1, s2 minus x1I plus y2 minus y1G. And that is exactly what we have here. Okay, so this is how to compute the displacement of a vector.